Hello and welcome to this short clip summarising the alkenes electrophilic addition mechanism. This is designed to go through some of the essential points you need to remember when writing this mechanism out. There are lots of different versions of this mechanism that are all slightly different from each other but say the same thing generally on the internet, so this is to try and clarify once and for all what you need to be doing to get this mechanism right for the specification we're doing here at college. So let's assume that our electrophile is bromine. First thing to do is to draw the partially positive bromine atom closer to the carbon-carbon double bond. The curly arrow must actually touch the carbon-carbon double bond and point directly to the partially positive bromine atom. The second curly arrow must touch the Br-Br bond and point directly to the partially negative bromine atom. So the carbocation must have a positive charge clearly indicated on one of the carbon atoms. A bromine atom is attached to the other carbon. So the curly arrow must start from between the electrons on the lone pair and the bromide ion, or from the negative charge on the bromide ion. And it must point directly to the carbon atom bearing the positive charge and the carbocation. I put the correct product for this particular reaction, I've decided to make it ethene, up in the top right hand corner, so don't forget to put the product in as well at the end. So the things to check as you go: partially positive bromine atom closer to the C-C bond, the correct dipoles, the curly arrow touches the carbon-carbon double bond and points directly to the partially positive Br atom. The second curly arrow must touch the Br-Br bond and point directly to the partially negative Br atom. Your carbocation includes a carbon that has a positive charge attached, like so. Curly arrow must start from between the electrons on the lone pair and actually point directly to the carbon that bears the positive charge. And finally, you have the correct product. So this time let's look at it with a polar electrophile. So in other words, an electrophile that already has a polar bond. Remember the bromine, although I didn't mention it in this particular clip, bromine is non-polar in the previous slide. That has to be polarized by the presence or the proximity of the electron density within the carbon-carbon double bond. So here again, touches the carbon-carbon double bond, and it points to the hydrogen atom clearly. Touches the hydrogen-bromine bond, points to the bromine atom clearly. So the curly arrow originates from between the electrons, the lone pair, or you can have it coming from the negative charge if you wish. One of those two is fine. It points actually at the carbon atom that bears the positive charge. Looking at the hydrogen that was part of hydrogen bromide has been added on here, and you get your final product, which is bromoethane in this particular case.